Well, now that you know how to simplify and mess around with radicals in fun ways like that, it's time to look into solving radical equations. Because what could be more fun than putting these things into an equation? Well, it's probably not as bad as you might think. First thing we want to do is just get that radical alone. So I'm going to go ahead and divide both sides by 2. And now, of course, to get rid of a square root, I need to square both sides. And then subtract 1. And just to be sure that everything's okay, I should probably just double check that because, square roots can be funky sometimes. So I'll go back to the beginning and I'll just double check that it works. So 3 plus 1 is 4. 2 times the square root of 4 is 2 times 2. That works. Everything's good. Okay, that didn't seem so bad. Now, number 2, got to be really careful here when you do some of these problems that you notice whether something's in a root or out of a root. The -1's out of this cube root, so I think I'll get that added over to start. Now, if I need to undo a cube root, then I probably need to cube both sides. So 3 cubed is 27. And now it's like a 2-step equation from, back in the day. So I'll just go ahead and add and divide, and I get x is 18. And again, just because this is kind of new stuff, it might be nice. I'm just going to go back and double check my answer because, I can just plug it back in. We know this. We haven't done it in a while, but we know how to do it. 2 times 18 is 36, minus 9 is 27. Cube root of 27 is 3, minus 1 is 2. So it works. Awesome. All right, let's try another one. So here's this one. There's that +4. It's out of the square root. So I'll go ahead and subtract it to the other side. Now to get rid of that square root, I've got to square both sides. Now, of course, -2 squared is 4, because when you square a negative, you get a positive. And then I'll divide by 2, and I get x equals 2. Awesome. So now, again, I'm just going to double check that. So I'll put this back in. 2 times 2 is 4. The square root of 4 is 2. And wait a second. Huh? Wait. I got an answer and it doesn't work. So I must have made a mistake, right? So let me double check. This was outside the root, so I needed to subtract the 4 first. That was correct. And 2 minus 4 is -2, so that was correct. And now that the square root is all alone, the next thing I have to do is square. So I square both sides and the square root just disappears, so that's correct. And I know -2 squared is definitely 4. I know that. I mean, this is what I'm doing. I'm squaring both sides. So I know that's +4. And then I know when I divide, that's 2. So what's going on here? Well, what you have is a situation in mathematics where the tools we use to solve can sometimes cause problems. The best way to describe this is I remember when I was a kid, there were times, sometimes when you have 2 parents in your house, there's the parent that's more strict and the parent that's a little more lenient. And in my house, my mom was the strict one. My dad was a little bit more lenient one. So most of the time, if we kids wanted to do something, who do you think we asked for permission? Well, of course, we went and asked Dad. And most of the time, when we'd ask Dad, which is like doing this solving process, and then later on, we asked what Mom thought of it, it checked out just fine. She agreed. So we followed the process of getting permission, just like solving an equation. And when we went back and checked with the boss later on, it just turns out okay. And every so often, we'd ask Dad if we could do something. And when we went back and checked with Mom, it didn't check out. And that solution was not okay. So it's much like this with math. There are times that we will do the solution process and we will get an answer. but the answer won't work. And the reason for that is because square roots have restrictions. We know this. No negative number can go into a square root, and no negative number can come out of a square root. But when we square both sides, that square root is no longer in this problem. That restriction is no longer there. And sometimes when we take that restriction away, we can get an answer that doesn't make sense. So even though we got this answer, we're going to need to cross it off because it doesn't check out. This is known as an extraneous solution. It's a solution we get as a byproduct of our process that when we check it back in the original problem, doesn't actually work. This is an issue with radical equations. You will have to check all of your solutions because you never know which one could be extraneous. Let's do a few more so you can see how this works. So next up, here's number 4. This one is a fun radical equation. I'm going to subtract the 2. And then I think while I'm at it, I'm actually going to convert this to root form. So I'm going to face plant my fraction. So I'm going to make that 4th root of 2x cubed equals 8. Now, if I want to get rid of that 4th root, I would need to do to the 4th power. And if I want to get rid of that cube, I would need to do a cube root or a 1/3 power. So now I need to go and do this math. Well, 8 to the 4/3, again, if I face plant that fraction and maybe use this version of it, the cube root of 8 is 2, and 2 to the 4th is 16. Of course, I could put 8 to the 4/3 on a calculator as well. And I divide by 2 and I get 8. Now let's go back and double check that in the original problem. 2 times 8 to the 3/4 plus 2. So that's 16 to the 3/4. Now 3/4 means I'm going to do the 4th root of 16, which is 2. Then I'm going to take that 2 and do it to the 3rd power, which is 8. And it checks out. So we're all good. This is my final solution, x equals 8. So things are going along great now, right? Yeah. And then along comes some new friends. Now we make things more complicated. You'll notice my square root is all alone. Yay, square root's all alone. But that's not necessarily helping us because the next step is that I need to square both sides. And this is where the mistakes start to happen. If I square a square root, the squaring cancels the square root sign and just dumps out the radicand. But when I square x plus 1, I do not get, not now, not ever, will I get x squared plus 1. No way, no how is that ever going to happen. I need to multiply that out. That is x plus 1 times x plus 1. I am going to need to multiply it out however I like to do it best, be it FOIL, in my head, or with a box. So I'm going to go ahead and do that math however I see fit. But now I have a quadratic equation. So I'm going to go ahead and bring everything over to the left-hand side so that my squared is positive. I always want to keep my squared term positive. Now I need to solve. And yes, I could do the quadratic formula, but I'm going to give you a heads up. in almost every math textbook, if you're solving a radical equation and you get a quadratic as your mid-step, it's a guarantee this is going to factor. So you might as well pull out your Xbox. Because Xbox is something we've done so many times before, I'm just going to skip to the already factored part. So this would come out as x minus 7 and x plus 2. Solving for my two answers gives me this. Now I'm going to have to go back and check them both in the original problem. So 7 plus 1 equals the square root of 7 times 7 plus 15. Well, 8 square root of 49 plus 15, that's the square root of 64. That checks out. X equals 7 is good. Negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. Negative 1 equals the square root of 1. Now remember, can I get a negative number coming out of a square root? If you put square root of 1 in a calculator, will it ever spit out negative 1? No, it will not. This is bad, which means this is extraneous. So this problem has one solution, x equals 7. If I go back to this problem where we first saw the extraneous solution, since the only solution we got was extraneous, this one would have no solutions. The only one we got was bad. But here we got two answers, one of which we threw away, one we keep. And so we only get the one solution. Now, in case you're thinking, oh, we just always throw away the negative one, not always. Sometimes it's going to be the positive one we throw away. Sometimes we get two positives and it's one of them that gets thrown away. All right, over here. So now with this example, what's important to know about this one is that in order to do this problem, you must isolate the radical. The root can never, ever have friends on the outside. So the first thing I need to do here is I need to get that square root by itself. If you think you know what to do here moving forward and you'd like to pause and try this on your own, go for it. If not, you can go ahead and watch the rest. I'm going to go ahead and square both sides. Now that I've squared this side, I'm going to need to multiply that out. Again, however you like to multiply things out, you can do it. I'm going to go ahead and just move to that step to save us on time. Since it's quadratic and my x squared is positive on this side, I'm going to go ahead and move everything over to this side on the left. Since I'm pretty sure it's going to Xbox because that's what these problems usually do, I'm going to go ahead and do that factoring. And now I'm going to go ahead and get both answers. Wait a minute, I got two positive answers now. Does that mean that they're both good? Huh, let's see. I'm going to put in the first one. 2 equals the square root of 2 plus 7 plus 5. That's the square root of 9 plus 5. Wait a minute. 3 plus 5 isn't 2. This is a bad solution. All right, let's hope for this one. There's always the possibility that they're both extraneous. So let's see. That's square root of 16 plus 5. Oh, that one does work. So we have the good one. And in case you're also now thinking, oh, I see the pattern. It's going to be that the little one gets thrown away. I wish I could tell you that patterns like that always existed, but they don't. You just have to treat each one individually and check it. Now, do you have to write out the check? No, if you can do that mentally and you can do it confident that you'll be accurate, then by all means do it. All right, so just when you thought things weren't fun enough, How about we make it even more fun? Yes, more fun, way more fun. Let's take a look at this one. You might say, but that's two radicals and they have different things and there's a +1. Now, if the +1 wasn't there, oh, this would be so much easier. I could square both sides. I'd be left with x plus 2 equals 3 minus x. This would be like the easiest problem to solve. But alas, the +1 is there and it is not under the radical. Oh dear. Well, I am going to go ahead and do what I know needs to be done. I need to square both sides. I wish I could tell you this was going to be pretty, but it is not. To square this side, I'm going to have to set up an unbelievably unpleasant box. Root x plus 2, 1, root x plus 2, and 1. Now, multiplying any root by itself is just going to dump out its contents. Here, I'm multiplying the roots by 1, so I get the same thing. Here, 1 times 1 is 1. So if I look at what this box produces, I get x plus 2, I get a +1, and then I get 2 x plus 2's in a root. On this side of the equation, thankfully, all that happens is I'm dumping out the 3 minus x. What this means is that now I've got to move everything over to the other side. I need to isolate the radical again. So I'm going to subtract this x. I'm going to subtract this 2 and this 1, so this 3. And I get 2 root x plus 2 equals negative 2x. Now, since this is even, and that's a 2, I'm going to go ahead and divide it out. And I get negative x. Now I have to square again. So this becomes the problem of the double squaring. So I square again, and I get x plus 2 equals x squared. Oh joy, quadratic. So since my x squared is positive on the right side, I'm just going to move everybody over to the right. And again, this is going to Xbox because that is what these things tend to do. And I'm going to get 2 answers. Now, when I go to check these, I must do it in the original problem. So I'll start with +2. Two plus 2 is 4. Yes. Square root of 4 is 2. I get 2 plus 1 equals the square root of 1. That is not true. That is not a solution. Let's try the -1. -1 plus 2 plus 1 equals the square root of 3 minus -1. All right, well, -1 plus 2, when I solve this one. So -1 plus 2 gives me 1. And that gives me 4. And square root of 1 is 1, plus 1 is 2. And the square root of 4 is 2. And so it turns out that in this equation, it's the negative answer that is our winner. And so there we are. So you can see this becomes quite the series of nasty problems. In fact, let's just make it one more step funner, and then we'll call it good. If you have 2 radicals on the same side, you cannot do it like this. You really can't. You don't want to. If you have 2 radicals on the same side, you have to split them up. Think about them like kids that fight. They can't be on the same side. You got to split them up. Don't ever let two radicals stay on the same side. Split them up. And then it's time for the squaring routine. So this side is going to turn out okay. This side, I'm going to box. And I'll have you trust me that that's how it turns out. Now I'm going to move everything over. So I'm going to subtract the x, add the 3, and subtract the 1. So I get x, and that's going to be -3. Now, because x minus 3 does not divide nicely by 2, I'm going to go ahead and square right now. Watch what happens with that. I'm going to square this side. On this side, I'm going to square the 2, which gives me 4. And then when I square the root, it just dumps out the x minus 3. You could have done that on the last problem, but I kind of like to divide them out whenever I can. I'm just a fan of that. So I'm going to distribute and subtract. So I'm going to bring over that 4x, and then -12, I'm going to add 12. And again, I am going to X box my happy little self into a factored equation. And I'm going to get my 2 answers. They're both positive. So now we got to wonder. I'm going to go back to the original problem. Always the original problem. 2 times 3 minus 5. And this one is 3 minus 3. Well, that'll be handy. That's just me 0. So I get the square root of 1 minus the square root of 0. That's going to check out. So that is a solution. Now let's do 7. The square root of 2 times 7 minus 5 minus the square root of 7 minus 3. Well, 2 times 7 is 14, minus 5 is 9. So I have the square root of 9. And 7 minus 3 is 4. Oh, hang on. Square root of 9 is 3. Square root of 4 is 2. 3 minus 2 is 1. They both work. So even though this one was kind of a pain, at least in the end, it turned out that both solutions were keepable. So it's not like we ended up having to throw away half of our good work. So if we go back to the very beginning, let's just write down now for ourselves, what are the steps? Step 1, isolate one radical per side. You want to try to get it as much alone as you possibly can. Square both sides, or cube, or whatever it takes. Although for the most part, we're going to be solving square root equations. We're then going to simplify. We're going to repeat numbers 1 through 3 if radicals remain. We're then going to solve for x. And then we need to check for extraneous solutions. And that is how we solve radical equations.